All right, third attempt here. Let's see if this one works. Today we are solving equations with variables on both sides of the equal sign. So, we're going to warm up with some two-step equations. We'll see if that shows up. Okay, how about now? There we go. We're ready now. So 4x plus 3 equals negative 5. You know we're going to subtract that 3 first. Negative 5 minus 3 is negative 8. And that's 4x. We just want x. So we're going to divide both sides by 4 there. Then negative 8 divided by 4 is negative 2. Nice. Now on number 2 here, we have some like terms to combine on the same side. 2x minus 8x. 2 minus 8 is negative 6. We have negative 6x plus 1 equals 43. And now it's a two-step equation. We'll subtract the 1. Negative 6x equals 42. And you know we're going to have to divide by that negative 6. And 42 divided by negative 6 is negative 7. All right, number 3 has the same thing. We have to combine those like terms there. So negative 7x minus 5x would give us negative 12x plus 4 equals 0. We'll have to get rid of that plus 4. We're going to subtract it. We'll see when stuff shows up. Maybe. Who knows? So while that's loading up, we're going to have one new step today, and it's to get the variables on the same side of the equals. So, okay, here. There we go. Let's see what we can do. So we're going to have to subtract the 4. Negative 12x equals negative 4, and then we'll divide by negative 12. Now we're going to get a fraction here, but we can simplify fractions. We're like pros. Negative divided by negative is positive. 4 goes into 12 3 times, so this comes out to positive 1/3. All right, cool. Find the value of x in the diagram below. Now, when you get to geometry, you're going to see stuff like this all the time. These angles that are opposites like this, they're diagonal from each other, they're called vertical angles, and they are equal to each other. So we could set up an equation here and just say 8x minus 21 equals 6x plus 3. So if we're running through our 5 steps, 6, we added the new one in here. Step 4 is to get the variables on the same side. So if we're running through our steps, there's nothing to distribute. There are no fractions or decimals to clear. Combine like terms on the same side. There's nothing to do for steps 1 through 3. So our first new step, step 4, is to get the variables on the same side. You can get rid of either variable. The 6x or the 8x makes no difference at all, but you get rid of it by doing the opposite. Remember, we're trying to cancel it out. So I'm trying to go from 6x to 0x. Easiest way to do that is subtract 6 from it. So if we subtract 6x on one side of the equal sign, we have to keep it balanced and do it on the other. Basically, if we're getting rid of a positive x, we're going to subtract it. If we're getting rid of a negative x, we're going to add it. So left side 8x minus 6x is 2x. Bring down our minus 21. The right side 6x minus 6x cancels out, so we just have 3. Now we're to step 5, undo addition and subtraction. 2x minus 21, we're going to add 21. 3 plus 21 is 24. So 2x equals 24. And we're going to divide that by 2. If I can move those steps out of the way, that would help. Now, come on a little further. A little bit further. All right, and then we will divide by 2. And 24 divided by 2 is 12. So, a curveball, but all we're doing is either adding or subtracting to get the variables on the same side. So let's hop down here. And these are the ones I'd like you to try. You can always get rid of either x by doing its opposite. Typically, I get rid of the smaller one, but either way will work out. So we'll do b together, and then I want you to try a and c. So on b, we have to distribute. 2 times x is 2x. 2 times -6 is -12. Clear fractions? Done. Combine like terms on the same side? We can't. We can't combine those. There are no more like terms. Step 4 is get the variables together. You can get rid of the 2x or you can get rid of the 9x. Makes no difference. I'm going to get rid of the 2x. It's positive, so I'll subtract it. Now, some kids would see the minus with the 12 and they'll be like, well, we'll add 2x to both sides. No, the minus belongs with the 12, not the 2x. If we added 2x, that would give us 4x. We're trying to get rid of it. 2x minus 2x is nothing, 0. So we have -12 equals 9x minus 2x is 7x, and you got your plus 2. Step 5, undo addition and subtraction. We're working on the side with the x. So I see plus 2, we're going to subtract 2. So -12 minus 2 is -14 equals 7x. Last step, undo multiplication and division, so we're going to have to divide by 7, which will give us -2 equals x. So try these other two problems, pause it, and I'll go over them pretty quick right now. So A, we can subtract an x, -6x minus another x would be -7x equals 4. We'll divide by -7, and you can't simplify 4 over -7, so we'll just leave it -4/7. Over here, our first step will be to get the x's together, so I'm going to subtract 5x from both sides. 7x minus 5x is 2x. So 2x minus 4 equals 16. We'll add that 4. 16 plus 4 is 20. 2x equals 20. And then we'll have to divide that by 2. 20 divided by 2 is 10. Great. You can buy used inline skates from your friend for $40, or you can rent some. Either way, you must pay for safety equipment. How many hours must you skate for the cost of renting and buying skates to be the same? So I always look at the last thing here. It says how many hours. We're looking for the number of hours. Whatever we're looking for is typically going to be our variable. So we're going to be looking for hours, and we'll call that H. Now we want to see when the cost is going to be the same for buying them or renting the equipment. So if you look at just the equipment, it's $1.50 per hour. Okay, so $1.50 times however many hours we work or skate. Plus, I also have to pay for the skates. So if I'm getting them from my friend, that's going to be $40. So plus 40. Now, it doesn't matter how many hours I skate, I'm still paying that $40. Or, the flip side of that is we can rent skates and safety equipment for $3.50 per hour. So, that does depend on the number of hours. We're going to pay $3.50 per hour, so $3.50 each. That's it. We don't have to pay like a standard skate fee. It's covered in that. Now, if we're trying to get the hours on the same side, I would get rid of the smaller one, which would be the 1.5. So we're going to subtract $1.50. $3.50 minus $1.50 would be $2. So we'll have 40 equals 2. You could say 2.00h. That's the same as 2h. And then here we just got to divide by 2. And 40 divided by 2 is 20. And remember, we're looking for the number of hours. So we're so cool that we're not going to say, if they're like, how many hours would you have to skate for it to be the same? You wouldn't say 20 equals h. You would tell them 20 hours. All right. Now this one's notice as you try, we'll kind of set this one up together. A hairdresser is considering ordering a certain shampoo. Company A charges $4 per 8-ounce bottle plus a $10 handling fee per order. Look, this is a word we've seen many times, per or each. It's going to indicate multiplication. So we're going to multiply $4 times however many bottles they are purchasing. Plus it says we have the $10 handling fee per order. So we only pay that once per order. Doesn't matter how much we order in that order, we're still going to pay that $10. Company B charges $3 per 8-ounce bottle plus a $26 handling fee. How many bottles must the hairdresser order for the cost to be the same? We're looking for the number of bottles. So company A, it's $4 per bottle. So 4B plus I also have to pay that $10 handling fee. So here's company A's fee structure. 4B plus 10. We want to know when that's going to equal the other place. B charges $3 per bottle, 3B, plus a $26 handling fee. There we go. There's when their costs are going to equal each other. Now we got to get the bottles on the same side. I would get rid of the 3B because it's smaller. So we would subtract 3 bottles from both sides, 3B. 4B minus 3B is 1B plus 10 equals 26. Ooh, nice. One more step. We got to get rid of plus 10. Let's subtract 10. 26 minus 10 is 16. B equals 16 really means 16 bottles. So if you were to order 16 bottles of this shampoo, is that what we're getting? Yeah. The cost would be the same either way. Now, if you were to order more than 16, then you're going to want to go with the cheaper option per bottle. So you would want to go with company B if you were ordering more than 16. If you were ordering less than 16, you'd want to go with company A. All right, now we got to distribute on this. We've done it before, so we're going to have to distribute first. So on A, if we distribute, we'll have 10 minus 8x equals 10 minus 8x. Okay. All right. Weird. So we can get the 8x's together. We can add 8x. All right. Here we'd have 10, negative 8x plus 8x cancels. Weird. Over here we got 10, and negative 8x plus 8x cancels. Oh my gosh, all the x's have disappeared. Now, what's left? 10 equals 10. Is that true? Yeah, that's true. So if all the variables cancel out, and you're left with something that is true, that's called an identity. Meaning you could substitute in any value in the original equation for x, and it would work out to be true, because it came out to the same thing on both sides of the equal sign. These are like rare special occasions. If we check this out on B, we got some combining like terms. On the right side I have 7x minus x. So 6x minus 5 equals, on the right side, 7x minus x is 6x plus 7. And then you're like, great, we can get the variables together. I'll subtract 6 x's from both sides. These cancel, you're left with negative 5 equals 7. Is that true? Does negative 5 equal 7? No, of course not. So if all the variables cancel and you're left with something that isn't true, not possible, you would say no solution. Again, these situations are special. It's only when all the variables cancel out. So if we were to keep that going for C here, we can subtract 5x from both sides. And we're left with 9 equals negative 1. Is that true? No, it's not. No solution. Only when all the variables cancel out. All right, now these are real doozies. These are like extreme examples of everything. So if we're running through our steps, distribute. A, there's nothing to distribute. B, we do. And D, we do. So on A, we skip that step. Step 2, clear fractions, done. Step 3, combine like terms. On the same side, you can't do anything on A. So we're already to step 4, which is get the variables together. So I would subtract 4x from both sides. If you wanted to get rid of the 6x instead, you could subtract 6x and it'll work. But we'd have negative x's, and I'd rather work with positive numbers when I can. So these cancel. We have negative 9 equals 6x minus 4x is 2x. And then we got that plus 7. Step 5 says work on the side with the x's and get rid of addition and subtraction. Plus 7, its inverse operation to cancel it out would be minus 7. Because that would give us 0. Negative 7 minus 9 is negative 16 equals 2x. The last step, undo multiplication and division. 2x because 2 times x, so we would have to divide by 2. Negative 16 divided by 2 is negative 8. Sweet. All right, on B, we start with a little distribution. 2 times 1 is 2. 2 times negative 2x is negative 4x. Now, some people, keeping in mind the last slide we just worked on, they'll start to get a little excited and they're like, ooh, 4x, negative 4x, they're going to cancel out. It's probably going to be no solution because we're left with two things that are not equal, 2 and 18. But negative 4x, if we wanted to cancel that out, we would add 4x. So we don't actually have the same amount of x's on both sides of the equal sign. Because these will cancel. We'll have 2 equals. Over here, 4x plus 4x is 8x. So they didn't go away as we had initially maybe thought. All right, 8x plus 18. That's minus 18. Subtract it from both sides. 2 minus 18 is negative 16 equals 8x. Okay, divide by 8. Negative 16 divided by 8 is negative 2 equals x. Nice. All right. Let's scooch that down. We'll need the space. On C, no distribution. Combine like terms. Left side I can do 4x plus x is 5x minus 5. Right side we have the 5x, and we can combine 7 plus 2 is 9. So 5x minus 5 equals 5x plus 9. We'll subtract the 5x from both sides. Cancel. Negative 5 equals. Cancel. 9. Negative 5 equals 9. What? No solution. Those aren't equal to each other. Silly. Oh my goodness. So silly. Oh my gosh. Now you're going to see this will look drastically different in 2 steps. So we got to distribute a lot here. 3 times 2x is 6x. 3 times negative 5 is negative 15. Negative 4 times 3x is negative 12x. Negative 4 times negative 1 is positive 4. We'll bring down the 11x plus 5. Over here, negative 5 times 6x is negative 30x. Negative 5 times negative 7 is positive 35. Negative 11 times x is negative 11x. And negative 11 times negative 3 is positive 33. Wow. Step 1, done. Step 2, combine all your like terms on the same side. So let's do all our x's first here. On the left, 6 minus 12 is negative 6. Negative 6 plus 11 would be 5. So we have 5x. Our regular numbers. If I was to do my positives, 4 plus 5 is 9. 9 minus 15 is negative 6. All right, that's all we have left on the left side. That's not too bad. Right side, if we combine our x's, we have negative 30 and negative 11. That would be negative 41x. Regular numbers, we have 35 plus 33. That's 68. See, I told you in 2 steps it's going to look all right. We gotta get the x's together. Old Mr. Plant's gonna add 41x to the both sides to cancel out the minus 41x. So that would give us 46x minus 6 equals 68. All right, we're gonna add the 6. (46x) equals 74. And you know we're going to divide by that 46. Now these are both going to be even numbers, so we could easily divide them by 2. Half of 74 is 37, half of 46 is 23, and then there's nothing that goes into 37 and 23 except for 1, so you can't simplify that. So yeah, these get pretty challenging, but we did it, man. If you look back, we got a lot of problems done today, and they were tough, but we did it.